Alright, welcome to quadratic and cubic inverses. Now number 1 says find the inverse function of f of x equals x plus 3 squared minus 4. Now let's go ahead and graph these two things first and foremost, and I'm actually going to add a little bit of an addition to my graph because this will actually help me graph them. You'll see it in a second. But I want to start by graphing the line y equals x. Now y equals x is easy. You put a point at the origin, you go up one, you go to the right one, you put a point, and then you simply just put a dashed line because that line isn't actually there, but it's something that's going to be true whether it's there or whether it's not. Now let's go ahead and tackle f of x, and what we're going to do is we're going to first graph this in orange. Now if you remember, graphing a quadratic is super simple. You take what's inside the parentheses, which we call our grouping, and you always set that equal to 0, and you simply solve for x. So we see x is equal to negative 3. So I'm going to write f of x, and we're just talking about the vertex over here. So I'll draw an arrow, and our x value is 3, and, negative 3. And whatever you see, whatever constant we have out to the right, that's going to be negative 4. So now I just go to the left, 1, 2, 3, down 1, 2, 3, 4, and I see that this is, it looks like it's actually going to be right below the line. There's our very first point. And then you look and see, well, hey, is my a value positive or negative? Well, we can see that there's nothing written there, so our a value is positive, and that just simply tells me that this function, let me just kind of graph it. I'm going to graph it a little bit wide. Okay, I'm going to graph it a little bit wide. It's going to look something like that. Pretend that's a perfect U shape. Now, the reason I do this is because I want to show you that you can actually graph the inverse function without really doing any work at all, if you understand a couple things. Thing number 1, whenever you find the inverse of anything, you're always taking your x and your y and you're switching them. So if the vertex for f of x is negative 3 comma negative 4, the vertex for f inverse of x should be negative 4 comma negative 3. By the way, let me use a different color here. Alright, negative 4 comma negative 3. And let's plot that. So we go to the left 4, we go down 3, and you should notice that this green point is the exact same distance from the line y equals x as our orange point. Now the next thing you want to notice is if you know how to graph a square root function, it's just kind of a gentle curve, but it's always going to intersect our other function on this line y equals x. So I can actually just graph it as such. Okay, pretty cool. Now the one thing that you should be aware of is that this green line, the square root, is actually the right side and only the right side of our original function. These two things are being reflected. You can probably see that from the red to the green, that is clearly the part that's being reflected. So what in the world is happening to this left-hand side? Why can't we reflect the whole quadratic? The reason is because at that point it's no longer a function. If you'll recall from Algebra 1, if we reflected the whole thing, it would look like a sideways U, but then it would fail the vertical line test. Okay? So that's why what we do is we essentially, whenever we do this, we actually wind up restrict the original function so that we don't take any of the left-hand side of it. We pretend that it's not there. Okay, now let's get to the actual math, because the actual math is pretty easy. Okay, we'll just go ahead and erase this. And what are our steps? We've done these so many times, these should be pretty natural. We take f of x, we change it to y is equal to x plus 3 squared minus 4. Think to yourself, what should be your next step? And hopefully you said we should switch our x and our y. We do that in a different color. So we say x is equal to y, and putting the rest of it back in here, we have plus 3 squared minus 4. Now we're just doing some very simple algebra to get y by itself. We know that we want to add 4 to both sides, so plus 4 plus 4. Now I have x plus 4 is equal to y plus 3 squared. And the big question here is, how in the world do you get rid of a square? Well, we're going to take the square root of both sides. Now our square root and our square cancel, and we actually wind up with this. The square root of x plus 4 is equal to, let's cancel, let's just put it back in our red, y plus 3. Now, normally we would put a plus or minus here, but remember, we actually don't care about this left-hand side because we can't reflect it. And so this is the one time that when you take a square root, you actually don't worry about the plus or minus. Okay, and if I could just go ahead and get rid of those. Oh, I see, I put so many little tick marks there. Okay, there we go. Okay, now from here, of course, we finish this off simply by subtracting 3 from both sides, minus 3. And just don't make the mistake of combining this 4 and this 3. They are not inside the square root together. So we can rewrite our final function as f inverse of x equals the square root of x plus 4 minus 3. And you'll notice here that that would give us this, it would give us this vertex of negative 4 comma negative 3 if you set the grouping inside equals 0. One final thing, what we have to say is we have to say that this is true, so I'll put a little semicolon when x is greater than or equal to wherever this vertex is. And since the x value of this vertex, we look at the x value of this vertex, and since it's negative 4, we say when x is greater than or equal to negative 4. Alright, well, let's move on to our second and much faster example. Okay, let's go ahead and graph f of x equals 2 parentheses x minus 6 cubed plus 1. Now once again, to graph anything in vertex form is super simple. We know that we'll always take our grouping and set it equal to 0. Here we add 6 to both sides, and x is equal to positive 6. So let's just go ahead and write f of x over here, draw a little arrow, and notice that my vertex is at 6 comma positive 1. Okay, let's go ahead and graph that. I go to the right 1, 2, 3, 4, 5, 6, and up 1. And then you have to know that the shape of a cubic function is something simply like this. Okay? And so notice one thing, we'll expect that this vertex will be reflected across the line y equals x, and we'll also expect that if these two things are going to intersect, they're probably going to intersect right there. Okay, so let's switch to a green function. Since we know the rule of inverses is we can switch our x and our y, we know that the vertex for this one will be at 1 comma 6. Meaning I go up 1, 2, 3, 4, 5, 6 to the right 1, and because it's reflected, it will just look something like, obviously I graphed this a little bit off, but that's okay. It'll look something like that. So graphing this is really easy when you understand that you just flip the x and the y of the vertex, and they're always going to have to intersect on the line y equals x if they intersect at all. Okay, now let's go ahead and let's see here. Let's go ahead and find our f inverse of x. So we know the usual. We switch f of x into y to parentheses x minus 6 cubed plus 1. And from here we'll do our big idea. We'll switch our x and our y, switch everything back to green. So x is equal to 2 parentheses y minus 6 cubed plus 1. And oh, this is going to look pretty interesting. Okay, so we are going to subtract 1, and we now have x minus 1 is equal to, putting it back in green, 2 parentheses y minus 6 cubed. And this is still not by itself, so the question becomes, how do you get rid of that 2? Well, since it's being multiplied, we're going to divide both sides by 2. And we now have, let me switch it back to this blue, x minus 1 over 2 is equal to, back to green, y minus 6 cubed. Now, you probably remember this from our solving homework. To get rid of a cube, all you simply do is take the cube root. And we take the cube root there. Pretty easy, those two things cancel. And so now we have the cube root of x minus 1 over 2 equals, sorry guys, I messed up my color scheme here, that's okay, y minus 6. Now from here, all we have to do is add 6. Notice that it cannot go on the inside, and so what happens here, those cancels, and I rewrite my y simply as f inverse of x is equal to the square root of x minus 1 over 2 plus 6, and notice I'll put my little semicolon here, and where x is greater than or equal to, oh, I'm sorry guys, So whenever you're worrying about a cubic function, you do not have to restrict the domain. You only have to restrict the domain whenever you're worried about a quadratic function. All right? These two examples should help you out with the remaining three. Good luck, and I'll see y'all in our next video.